500 years ago, the Aztec civilization in today's Mexico believed that the sun and all its power was sustained by the blood from human sacrifice. But today, we know that the sun is powered by a reaction known as nuclear fusion. If we could replicate something similar on our planet, we would finally be able to crack the code for virtually limitless, clean, safe, and affordable energy to meet the world's ever-growing energy requirements, energy demands. It looks like China just figured out a way to make nuclear fusion a reality with their new nuclear fusion reactor. So keep watching till the end to find out a lot more about something that might finally solve the ever-growing energy demand. At least 74% of the global energy by 2050 will be from renewable sources of energy. The introduction of renewable and energy sources like wind and solar show the world that we can have sustainable sources of energy. But it comes with a problem, and that problem has to be intermittency. That's when we began to look for alternate energy sources that are sustainable and do not produce greenhouse gases, unlike the energy sources that are based on fossil fuels. That's where nuclear fusion came into the picture, and today it is touted as the future of clean and net zero carbon energy. So how exactly does nuclear fusion work? Nuclear fusion is the process by which two light atomic nuclei combine to form a singular, heavier one while releasing massive amounts of energy. Fusion reactions take place in a state of matter called plasma, which is just a hot charged gas made of positive ions and free-removing electrons that has unique properties distinct from solids, liquid, and gases. On our sun, nuclei collide with each other at extremely high temperatures exceeding 10 million degrees Celsius to enable them to overcome their mutual electrical repulsion. Once the nuclei overcome this repulsion and come within a very close range, the attractive nuclear force between them will outweigh the electrical repulsion, forcing them to fuse. For this to happen, the nuclei must be confined within a small space to increase the chances of collision. When you look at our sun, the extreme pressure produced by its immense gravity creates the conditions that's necessary for fusion to happen. The amount of energy produced from fusion is extremely large. We are talking about 4 times more than nuclear fission reactions. This means that fusion reactions can be the basis of future fusion power reactors. The very first generation fusion reactors might use a mixture of deuterium and tritium, both of which are heavy types of hydrogen. In theory, by using a few grams of these reactants, it is possible to produce 1 terajoule of energy, which is the energy used by one person in a developed country over 60 years. China is already leading the world by being the world's factory, but the country wants to take it to the next level with their ambition to generate near limitless clean power through nuclear fusion energy. The country is already closer to reality with their new nuclear fission reactor. The country's leading nuclear scientists already predicted that the nation will achieve nuclear fusion energy within the next 6 years. The country is already aiming to create nuclear fusion energy by 2028, being the world's first to achieve large-scale energy fusion. This will be a huge milestone in the road to making fusion energy viable for human beings, as nuclear fusion is already dubbed as the holy grail of energy sources. It has to do with the fact that these energy sources will be able to provide endless energy by mimicking the natural events that occur in the sun, or massive energy is released when hydrogen atoms collide to form helium atoms. Nuclear fusion also does not emit carbon dioxide or any other greenhouse gases into the atmosphere, so this might help us mitigate the issues that we have with any other forms of energy, including nuclear fission. There are several significant technical hurdles for something like that to even become a reality. The sun weighs about 333,000 times more than what the Earth does, which means it is capable of producing powerful gravitational forces that produce extreme pressures. This pressure, combined with a temperature of up to 15 million degrees Celsius, gets atoms to fuse together. So how can we replicate something similar on Earth? Well, right now we don't have the technology to recreate the sun's massive pressures, so researchers have to make up for that by getting hydrogen atoms even hotter than the sun by raising the temperatures to 100 million degrees Celsius. This can be achieved by using several tools like particle beams, electromagnetic fields such as microwaves and radio waves, and even lasers. The temperatures needed are so hot that the hydrogen fuel becomes a plasma, which is a state of matter that exists when an atom splits into positive and negatively charged particles. There are several reasons why fusion power is so difficult to achieve. One big reason requires working with plasma, because it's quite tricky to deal with plasma. Plasmas are not so common, and scientists have very little experience dealing with them. Plasma used in fusion energy research cannot be placed in a solid container because the container would just melt. Plasma is also difficult to compress. To put things into perspective, imagine holding a large squishy balloon. When you try to squeeze it as much as possible, no matter how evenly you apply pressure, the balloon will always try to find a space between your fingers. China Fusion Engineering Test Reactor, or the CFETR, is a proposed tokamak fusion reactor which uses magnetic fields in order to confine plasma and generate energy. Presently, the tokamak devices are the leading candidates for construction of a viable and practical thermonuclear fusion reactor. The Chinese power plant will be relying on the Z-pinch machine, which uses a strong electrical pulse to simulate the fusion reaction of a thermonuclear bomb. The machine is anticipated to be finished by 2025 in Chengdu, the capital of Sichuan province. These reactors will be used to generate sustainable energy while also ensuring low environmental impact and much smaller carbon footprint than what we have with fossil fuel-based power plants. The fusion reactor utilizes and intends to build upon the pre-existing nuclear fusion research from the ITER program in order to address the gaps between ITER and the next-generation thermonuclear successor reactor class to ITER, the demonstration power plant. We already have 3 domestic fusion test reactors that are operating in China. These include East and ASIPP, a Hefei, HL2AM, at the Southwestern Institute of Physics, SWIP, at Chengdu, and JTEX, located at Huazhong University of Science and Technology in Wuhan. Additionally, as of 2021, in an effort to more accurately simulate a potentially functionally operational CFETR, the HL2A at SWIP was upgraded to the HL2M. Construction for the HL2M was completed in November 2019, and the device was commissioned on December 4, 2020. The CFETR will be operating in 2 phases. During the first phase, the CFETR will be required to demonstrate steady-state operation and tritium self-sufficiency with the tritium breeding ratio greater than 1. Moreover, during the first phase, the CFETR should also demonstrate generation of fusion power up to 200 megawatts. During the second phase, the demo validation phase requires the CFETR to generate power over 1 GeV. It will also serve as a research and development tool for testing out various structural and functional materials you identify and develop a material with high neutron flux resistance. The machine will generate 50 million amperes of electricity, and this figure is approximately twice as much as the record-breaking Z-Pulse power facility, a machine that is comparable to the one at Sandia National Laboratory in the US. These machines are used to produce atomic weapons, and only recently they have been considered to be used to generate nuclear fusion energy. Over the past 3 decades, nuclear powers including China, Russia, and the US created several Z-pinch machines to recreate the harsh conditions that are required to produce atomic weapons. Chinese scientists claim that they use different techniques than those employed in the West, while also arguing that their approaches will be more effective than the ones that we already have, despite all the obstacles in making nuclear fusion a reality. If China is able to stick to their deadlines, this might supply energy needs for tens of thousands of years, which already sounds like good news. Beijing is already making huge progress in this area, while also intensifying its initiatives to generate infinite clean energy. The country also holds the record for employing an artificial sun for a reaction that lasted for more than 17 minutes at a slightly lower temperature of 70 million degrees Celsius. South Korean researchers also announced that they have successfully maintained their nuclear fusion reaction working at temperatures over 100 million degrees Celsius for the very first time, but just for 30 seconds. China Fusion Engineering Test Reactor is the next big thing in the roadmap for the realization of future fusion energy in China, with which the country will be able to bridge the gap between fusion experimental reactor ITER and demonstration reactor. The prices of renewable energy are also going down, which means economic viability of fusion power will still be brought to the forefront of future economics of energy. Economists already suggest that the future of fusion power is unlikely to be as cheap as other renewable energy. This is because fusion plants, unlike fission, will require large startup and capital costs, as the cost of materials, infrastructure, and machinery required to construct these fusion plants will be exorbitant. But we cannot overlook China's confidence with their new reactor, and only time will tell whether nuclear fusion will be a reality anytime soon.